I think we all know how it works. Like if you take the absolute value of negative 6, what's the answer? 6. What's the absolute value of positive 6? It's also 6. How can it be two different numbers in that absolute value and get the same answer? Why is that? Kinda. That's a good interpretation of it, but it's not exactly the dead-on definition of absolute value, but it does relate to that very much. What do we know about negative 6 and positive 6 in relation to one another?
Same numbers, different.
Okay, so what's it mean to be a negative 6? Below what?
Below 0.
Okay, to be a positive 6, you're above 0. Okay, so why is their absolute values the same? It's still 6 units below 0, and then positive 6 is 6 units above 0. So that absolute value, the reason negative 6 and positive 6 have the same absolute value is because they're the same distance away from 0. So that's what absolute value really is. It's a distance away from 0. So that's the real definition. Distance from 0. So that's what absolute value really is. So when we set up absolute value equations, we've got to deal with the fact that it could be, if it's equal to, absolute value of something is equal to 6, it could be talking about 6 units on the positive side of 0. But it also could be talking about 6 units on the negative side of 0. So we've got to take into account both of those options when we're talking about absolute value equations. So that distance away from 0 is what causes us to have to do really 2 equations every time we do an absolute value equation. Okay, so what we're going to do is start with the problem. Let's just solve. Absolute value of x is equal to 4. Okay, so what this equation says, it says x, some number, has an absolute value of 4. So some number is 4 units away from 0. What numbers are possible? 4 and negative 4. So we could have 2 equations. The inside of the absolute value is x. It could be positive 4, but it also could be negative 4. Both of those numbers have a distance away from 0 of 4. Okay? This one's nice because is x by itself in both equations? Yeah, so we don't have to do any work for that one. Where it gets a little bit more complicated is when we have something like x plus 3 in absolute value is 6. Okay, so here we have x plus 3, whatever this is 6 units away from 0. So that means x plus 3 could be at what number? X plus 3 could be at positive 6, but it also could be where? At negative 6. So we have to set up 2 equations. X plus 3 equals positive 6, and x plus 3 equals negative 6. Then x is not by itself, so I got to do the work of solving it and getting x by itself. So I subtract 3 on both sides. X is equal to positive 3. And I think that's the one y'all were talking about when y'all were saying 3. X could be 3. That's right. But when I do the same thing over here to solve that problem, I get negative 6 minus 3, which is negative 6. Negative 9. Because if I owe you $3 and then I borrow 6 more, now I owe you $9, right? So that's negative 9. So when x is positive 3, then the absolute value of x plus 3 is 6. If x is negative 9, the absolute value of x plus 3 is 6. Okay? These numbers, the only time that they will match is if there's nothing else inside of the absolute value. Okay? Common mistake with this stuff is that most people will just solve the positive one and then put x equals 3 and x equals negative 3. Well, that's not right. That's not how it works. Okay? You've got to set up 2 separate equations and solve them. Okay? Look at another one. Let's say we had absolute value of 2x plus 5 is equal to 13. So absolute value of something is 13 units away from 0. So we set up two equations. What are the two equations that we would set up for this problem? 2x plus 5 is equal to what? One needs to be negative 13 and the other one positive. And then we solve that using the same skills that we've been using since August. Okay, we get x by itself. So just doing one at a time. So if we do this one, what's the first move to get x by itself on 2x plus 5? Subtract the 5. So you have 2x is equal to negative 18. And then divide by 2. Negative 9 is x. And then the other side, same steps. Still going to subtract 5. 2x equals positive 8. Divide by 2. X is positive 4. Notice those numbers are not the same number. You know, one positive, one negative. That's not how it works. You've got to set up two separate ones and solve those. Now, where they kind of start muddying the water a little bit is when they start throwing other stuff in there. Where they have absolute value of x plus 4. And then they, outside of that, they have a minus 3 is equal to 6. Okay? Well, every problem, the first three that we did, the absolute value part was just the only thing on that side. Can we make that problem look like, this problem look like that? How? If I add 3 to the 6 over there, it'll just, only thing left over there will be that absolute value of x plus 4, right? That's what I need to do first. I need to get the absolute value stuff by itself before I set up my two equations. Okay? So here I'm going to add 3 to both sides. And there's my absolute value of x plus 4. 6 plus 3 is 9. Okay? Now I've got a problem where we've got something has a distance away from 0 of positive 9. X plus 4 is 9 units away from 0. So our two equations that we would set up for this problem are what? Equals positive 9, and then x plus 4 equals negative 9. And then we solve each of those individually. Okay? Key thing is you've got to get the absolute value part by itself before you set up your equations. If you don't, you're going to set up equations with the wrong numbers in them. Okay? If we'd have set this one up, we'd have had it equal to positive and negative 6, but that's not where it's at. That's 6 units away from 0. 6 units away from 0 is not the same as 9 units away from 0, right? It's kind of like the distance from here to Savannah is not the same as the distance as here from here to Jackson. They're two different places. 6 and 9 are two different places there. So that's why you got to get that absolute value by itself. So what operation do I use to solve this? Subtraction of 4. Okay. Negative or 9 minus 4 would be 5. So x equals 5. Same operation on the other problem. What's negative 9 minus 4? Negative 13. You get two answers there, 5 and negative 13. Both would be 9. When you plug it in here, gives you that distance of 9 units away from 0 when you add the 4s. All right, so this one has a 4 on the outside of the absolute value, and then x plus 5 on the inside, but it's equal to 12. Is the absolute value part by itself? No. What's wrong with it? What's going on between that 4 and the absolute value part? It's multiplication. So how do we get rid of that? Divide. Okay, so we're going to divide by the 4. When you're dealing with absolute value, never distribute. Okay? If you're dealing with absolute value, never do distributive properties. Always just work from the idea of getting rid of that number. Don't ever distribute. Now, divide by 4 is 3, so we get this absolute value of x plus 5 is equal to 3. What are our 2 equations that we set up? Yeah, x plus 5 is equal to positive 3, x plus 5 is equal to negative 3. It doesn't matter what order you put those, which one you do first or second. It doesn't matter. With equations, it's the same. So that'd be negative 2. Subtract 5 over here. There's negative 8. So we get 2 solutions that would both go into the original problem and get us the right number there. Okay. Again, we got to make sure we get our absolute value by itself. I'm going to need a little more space than that. So let's go. Example F. 3, absolute value of 2x minus 7 minus 5 is equal to 4. Let's ramp up pretty quick here to get to something that makes sense. So what are we trying to get by itself first? The absolute value part. So which numbers on that side are not in the absolute value? The 5 and the 3. So we got to get rid of those. Which one do we get rid of first? Why? Yeah, when we think about working backwards to solve something, subtraction is later, it's what happens. You undo that part first. The last thing we want to undo is the multiplication there. The 5 is not directly attached to the absolute value. That's kind of what you want to think about. The 3 is attached by the multiplication. So the 5 is easier to move. So we're going to move it first by doing what? Adding. So there's 3, absolute value of 2x minus 7 is equal to 4 plus 5 is 9. So almost there. How do we get rid of that 3? Yeah, divide by 3. Absolute value of 2x minus 7 is equal to 3. And we're still not done. Now we can set up an equation, or 2 of them. What are our 2 equations? 2x minus 7, whatever's on the inside of the absolute value, is equal to negative 3. And then 1 is equal to the positive side. And then solve each of those. So what's the first move to solve this problem? Add 7. 2x is equal to 4. Divide by 2. X is equal to 2. There's one answer. Same operations to solve the other problem. We'll add 7. 2x is equal to 10. Divide by 2. 5. Positive 2 and positive 5. All right. G. Oh, yeah. 2/3. Everybody loves a fraction. Absolute value of 4x minus 5 plus 10 is equal to 16. Okay, so we got similar problem to what we just did. Just got a fraction in there, so kind of can make it a little more difficult. So again, what are we trying to get by itself before we set up our 2 equations? Absolute value. So what's the first thing that should be moved? Move the 10 because it's not directly attached to the absolute value like the 2/3 is. So we're going to move the 10 by doing what? Easy math, 2/3, 4x minus 5 in the absolute value, 6. Now what? Divide by 2/3, which is the same thing as multiplying by the reciprocal, 3/2. So those are the same operations. All right, so 6 times 3/2. 18/2, which would be 9, right? Absolute value of 4x minus 5 is equal to positive 9. So set up two equations. What are my two equations? So 4x minus 5 is equal to positive 9. 4x minus 5 is equal to negative 9. Solve them. We'll add 5. 4x is equal to 14. What's the next step? All right, so next step is do what? Divide by 4. That's right. Next step. And then what do we do with this? What will go into both of them? So 14 and 4 are both even numbers. So what do we know goes into? 2. 2 goes into 14 7 times, and into 4 2 times. So there's the 7/2. Leave it as that improper fraction, but reduce it all the way as far as you can. Okay, and then we just need to do the other problem to solve it. Again, same operations, plus 5, negative 4. Last step, divide by 4. And what's negative 4 divided by 4? Negative 1. So there we get two answers. It's okay for one of them to be a fraction, one to not be. And it's okay to have negative answers. That's all part of the game there. All right, let's see. Maybe we have something like this. Absolute value of x plus 5 over 2 is equal to to 11. That's a good number. These sometimes can be the confusing ones, but they're not much more difficult than the other ones. It's just got to think about what's going on between the absolute value stuff and the 2. Why am I timesing by 2? Yeah, when it's written like that, that's division, right? Yeah, you guys got the right idea. So we just multiply by 2. So that's 22 is equal to x plus 5 in absolute value. What are our two equations? Yeah. And solve those. Subtract 5. Get negative 27. And then 22 minus 5 would be 17. So not too bad. Those can kind of look weird, so I want to try to show you one of those. All right. Go back to a simpler idea, and let's get a concept down here. Absolute value of x is equal to negative 8. What do we know about absolute value? We started out with the two problems, absolute value positive 6 and absolute value negative 6, and both of them turned into just plain old positive 6. What does that mean about absolute value? It's always positive. Why is it always positive? Think about, go back to the essential idea of what absolute value is. It's a distance. What do we usually use to measure distance? This little cheap tape measure here. I pull that out. What kind of numbers are on there?
1, 2, 3, 4, 5.
What kind are those? Positive. They're all positive, right? So anytime I measure how far something is or how long it is, it's positive, right? So can absolute value ever be negative? There's no such thing as negative distance. Okay? So when you get this kind of situation where you have absolute value by itself and it's equal to a negative number, it's going to be no solution. Because absolute value can never be negative because it's a distance. And distances are always positive. When we're measuring distance, it's always positive. Okay? Well, you guys have never seen Ferris Bueller's Day Off, probably. But he takes his dad's sports car out and he drives it around all day and then runs up a bunch of miles on it. And his dad's real picky about it. So he thinks that if he puts the car in reverse, that it will roll the odometer back. It doesn't work that way. That's still mileage on the car and it still counts up. It goes positive distance, okay? So positive distance, there's no way absolute value can be equal to a negative. Anytime you see, doesn't matter what's inside of the absolute value, but if it's equal to a negative, we know it's no solution. We don't have to work it, okay? They're very rarely going to give you one that's that simple. They're going to throw this at you and say, figure it out, kid. But why is it no solution? Show me how you arrive at the fact that J is no solution. What do you have to get by itself first? The absolute value. Before we can set up our two equations, we'd have to get absolute value by itself. So the first move would be subtract 8, right? So the absolute value of 2x minus 3 is equal to, what's 2 minus 8? Negative 6. Here is the statement that says, oh, now it's no solution because we have an absolute value. It's got 2x minus 3 in it, but that really doesn't matter. Its absolute value by itself is equal to a negative number. So that's saying a distance is equal to negatives. That doesn't happen. Can't have that. So this is a no solution. That doesn't happen that often. Okay, so don't expect, out of the 20 problems you got to do, don't expect 5 of them to do that. That's not going to happen that often. Negative 4, absolute value of x plus 5 plus 13 is equal to negative 3. So with this one, it's equal to a negative, right? So it's no solution. Maybe not. Why can I not decide that yet? I got to get the absolute value part by itself. I got to do that solving part first because it may change signs. So what's the first step? Drag 13. Good job, guys. You would not believe how infinitely better you guys are at solving equations than you were 2 months ago. What's negative 3 minus 13? Negative 16. Okay. Is absolute value by itself yet? No. What else has happened? Not multiply by 4. Divide. They're multiplying, so we're going to divide by 4. 4? Negative 4. That's a negative 4. So I'm going to divide by negative 4. Oh, man. Negative 16 divided by negative 4 is, oh, man. Is this no solution? No. We got an absolute value equal to a positive number. That means we can work this one. Okay. 2 equations. Solve them. Negative 1. -9. Don't jump the gun when you're trying to find ones that are no solution. Again, they're not going to happen that often, but you've got to have the absolute value part by itself before you can decide. Okay? If you get absolute value by itself and there's a negative on the other side, then it's no solution. You'll have to work it. Be careful. Sign mistakes can get you here very much. Just like they can on everything we've done so far. If it's supposed to be positive and you wrote a negative, it's a different number. It's not going to work out the same. Okay, so got a few problems here, kind of mixed together of the absolute value equations, and knock these out today. Tomorrow we're going to do absolute value inequalities. So knock these out today. And the inequalities relate back to what we did last week with the compound inequalities, the and or problem. So you haven't completed that handout, you probably need to take a little time to do that today. Thank you.